Hello there. Welcome to our today's science lesson. The topic for the day being chemical properties. In our previous lesson, we looked at the physical properties of substances, and we realized that in physical properties, we only try to look at the description of a substance physically. And physically here I mean you maybe look at the texture, the height, the state at room temperature, the temperature in which it exists under normal conditions, that's at room temperature, and so on. In short, you are only looking at the physical aspects of the substance, which are mainly identified or can be pinpointed using the five senses, which we all know, the five senses. But now, looking at the physical properties, they are totally different from chemical properties. In which sense? Physical properties, even if there is a change, that change can always be reversed, meaning that the chemical composition of the substance is always maintained when you are talking about any change that involves physical aspects of the substance. But in our today's lesson, we want to look at chemical properties, and to start with, we need to understand first of all what is a chemical change, so that from the chemical change, then you can say this is the property we are trying to maybe understand more, or we are trying to investigate. Remember, we are in science, and science is about investigations, experiments, to find out more about issues. Now, in chemical properties, we need to understand that for a chemical change to have taken place, it means the internal arrangement of the substance changes. Once a chemical reaction has taken place, the new substance or the substance that is formed after that will always be different from the original substance, both sometimes in a physical way of description, but in addition, which is the most important, the chemical way of description. When I say physical way of description, being different or the same, it can be, for example, color. Something can undergo a reaction, but still maintain the original color. But that does not mean that the chemical way of describing the substance will remain the same. I will give out examples in so many of these cases, and we shall see the differences between physical and chemical changes, which puts in itself the description way of stating the physical properties or the chemical properties. When we talk about properties, we are looking at the descriptive way of looking at the substance. But when you talk about physical change or chemical change, you are looking at the reaction way of describing the substance. Now, in chemical changes, that is in describing a substance chemically in terms of its properties, there are common reactions that we need to understand. Very common, and being very common, we take them to be the most basic that we need to know, so that from there we can build and know much more about others that we may think are beyond maybe our level, but at one time you will be at that level. So the first chemical description to show us the chemical properties is about combustion. Combustion. When you look at combustion, combustion is just burning or a substance undergoing explosion. Burning or a substance undergoing an explosion. If maybe you are a fan of movies, you have seen where maybe a grenade or a bomb has been used, and after that, what you always see is fire. Maybe you were asked by your guardian, your teacher, or yourself. You had some trash somewhere, you ignited, that is, you had maybe a matchbox. What did you see? You saw fire. That is combustion. And what about this combustion? Combustion, therefore, is just that aspect of the substance, reacting with air, and in air, our point of interest is oxygen. When you talk about combustion, when you talk about that burning, when you talk about that explosion, that is, you are seeing at the end of it all a fire. Then what you are seeing is a substance is undergoing a reaction by the substance being combined with air, and in air our point of interest is oxygen, so that at the end of it all you form an oxide of the substance. So this one gives us an oxide of the substance. Now these oxides can be in different forms. The oxides can always be in different forms depending on the substance that is undergoing combustion. Maybe it's good we give an example here. If you have wood, you are burning wood, which is the same as paper. Remember, paper comes from wood. So you are burning paper, or you are burning wood. What you will be seeing is, at the end, you will form ash. This ash forms the oxide of the wood. Now, that wood is not as simple as you are looking at it. Wood is an accumulation of so many chemical elements in it. Remember, if it was wood from a particular plant, this wood from a particular plant, this plant was nourished with so many, maybe types of fertilizer, some elements were just absorbed from the soil, and so on. So when you look at wood, wood is not just wood as simple as it is. It is an accumulation of so many elements. So those elements are the ones during the process of combustion that combine with the air, that is oxygen, to form an oxide. So if I can give an example of an element that is found in wood, and from that we can now get our oxide. An example is sodium. We have sodium, and that's why I've picked on sodium, because sodium is one of the biggest element in wood by percentage. That's why when you burn wood, you see a yellow flame. When you look at higher levels of study, when you will be looking at things like flame test of cations, you'll discover that when you test sodium using the spectrum of sodium, spectrum tests, the spectrum of sodium will be a yellow color. So when you have sodium in that wood, I'm only interested in sodium, then you react with the air, and in air I'm talking about oxygen, then what you will form is sodium oxide. Sodium oxide. So in general, during combustion, we have combined with the oxygen. Now, our point of interest here is not even the reaction. Our point of interest here is to note the difference between a physical change and a chemical change. A description of a physical property and a chemical property. What we saw in physical properties is the result and the reagent are the same in terms of properties. They may change, maybe things like color, which can be reversed, maybe state at room temperature, which can be reversed. But look at this. Is sodium oxide the same as oxygen? Or is sodium oxide the same as sodium? Obviously not. So what we are seeing now is a chemical change. So this is a chemical property that the change is irreversible. as one of the chemical property. The change is irreversible. Another property is the new substance is different from the reagents or the original substances by identity, which is true. This is sodium oxide, but this is oxygen, and this sodium. By mass, if you look at the mass of sodium oxide and oxygen and sodium, this one are all of them are totally different. Energy is involved in all chemical reactions, and it is true. It was during combustion that we got this. So energy is involved. So there we can see chemical properties. Let's look at another example, which is common. Remember, I'm talking about the common chemical changes that will show us our chemical properties, to show the difference between physical properties and chemical properties. So second to combustion is corrosion. Corrosion, or we also have rust. Corrosion, or we also have rust. Now, during corrosion or during rusting, and I think rust is very common to our eyes, so I will mostly dwell on rust. If you find a new piece of iron metal, and try to describe it in terms of appearance, you'll discover that if you touch on the surface, it will be smooth. If you look at the color, it will be gray, or sometimes even shiny gray. I'm talking about iron. If you try to bend it, it can bend comfortably. If you apply enough pressure, it will bend. But after some time, when exposed to conditions necessary for rusting, and that is the presence of oxygen gas and water, presence of oxygen gas and water, which are conditions necessary for rusting, then after a certain period of time, let's talk of maybe a month, 2 years, 1 year, 10 years. And when I mention this long period, I'm sure at one time you must have passed a place where maybe a certain piece of junk, for maybe a vehicle or any kind of machine, has been left to stay there for a very long time. So I'm talking at such a piece of metal. If you do the same by describing the surface of the metal, I'm sure the description will be different. One, the surface will not be smooth. If you try to feel the surface of that piece of metal, that wreck that has been left for a very long time, it will be rough, not as smooth as it was. If you look at it in terms of color, it will not be gray. Instead, it will be red, sometimes red-orange. If you try to bend the metal, it breaks without warning. What we call, it becomes brittle. So what has it to do with the rust in relation to chemical properties? Rust in relation to chemical properties. It has everything to do with the change of what you had previously to what you have presently. So previously what you had was iron metal. This iron metal is in the presence of oxygen. It's in the presence of oxygen. Let me use words. So we have oxygen. Then also we have water. Because of that, we end up with a new thing, what we shall call hydrated. Hydrated means with water. Just like when you say, I'm dehydrated, please assist me with some water. It means you have lost water. I'm well hydrated, I'm comfortable. It means you have enough water. So when you say hydrated, then it means that substance has water. What is it that is hydrated? Iron. Now, because of that, it underwent reaction with the oxygen to form now iron oxide. To form iron oxide, hydrated iron oxide. But now, you also need to realize that this iron, we have two types of iron. It exists in two different ways, just like you. You exist in two different people. There is that you who is at school. You will behave totally differently. But there's also you at home. You can imagine probably during over weekends, you have just been told by your friends, or you are already aware that you are supposed to go and maybe catch up with a movie somewhere to have some fun with your friend. The way you will be carrying yourself, the way you will be behaving, I'm sure will be totally different from the way you are behaving right in front of this class, or in this class, or in this environment of learning. So these are two different people, though they are the same, coming from the same, but two different people. So even this ion has two, what we call two oxidation numbers. So it has, we have ion 2 and ion 3. So what we have in rust, is ion 3 oxide. Ion 3 oxide, and is the one that gives the characteristic color of this rust, which is red. Sometimes we call it a red orange, hydrated ion 3 oxide. So that is the correct name of rust. You have to be different from somebody who is not learning science. So for that person, we'll call it rust. And for you, you will now call it in a scientific way that it is not rust. Rust is too common. Let's call it the way it's supposed to be called. It is red-orange hydrated iron 3 oxide. But now, let's look at it in terms of chemical properties. Look at this and relate it to this separately. Are they the same? Obviously not. Iron is singled out as ion. This oxygen on its own, water on its own, but here all the three have been combined together. And you cannot reverse this ion back to any of those three unless you do it using chemical means, but physically you cannot. So in such we say these are chemical change, and therefore whatever we are seeing, chemical properties are able to be identified. The other common thing we can look at is describe substances. The other common thing we can look at is describe substances in terms of, are they either acids or bases? Describe substances for you as you are looking at chemical properties in terms of, are they acids or bases? Why? Because these are the common things we interact with in our daily life as either liquids, gases, solids, and so on. And by interacting with them, we want them to be either an acid or a base, including even the drugs we take. When you are maybe ill, you will be told this type of drug, you are supposed to take it in this format, just because probably you haven't been told by maybe the doctor, but since the doctor is knowledgeable enough, will tell you when you are taking this drug, make sure ABCD is also added, just because the drug is either known to be acidic or basic. And lastly, what you also need to understand as basic knowledge when it comes to chemical properties is, now we are talking about reagents reacting to form products, and products are totally different from the reagents in all aspects. But one thing must come out very clearly: how fast or how slow is the reaction. do all these reactions take place at the same speed? Now what we call rate of reaction. Rate of reaction. So we look at the rate of reaction. Do all these reactions take place at the same rate? Obviously not. Let's take two examples and see that they are all chemical reactions, but they take place at different rates. Compare rusting and combustion. Compare rusting and combustion. Do the two reactions which are showing chemical properties proceed at the same rate? Not at all. Combustion is a faster reaction, but rusting is a slower rate, a slow based reaction. If you leave a piece of metal in water, you may require even more than a day for you to realize that surely there is a red substance that has been formed on the surface of that iron piece that you can now call rust. But look at combustion. Once you ignite, it starts burning. Within a short period, you will now be talking about ash. So you can say in combustion, the rate of reaction is faster. But in rusting or in corrosion, the rate of reaction is slow. So these four are some of the very basic ideas, concepts we need to understand when we talk about chemical properties of substances. But why are we learning this? Why are we learning chemical properties of substances? We are doing this so that we can be acquainted, we can be given that power of choosing or predicting which material is better or is best used in particular areas. So we have to be able to choose to predict materials that can be well used to give good performance, to give good results in particular areas. That's why we are talking about chemical properties. Remember, in one way or another, that substance will interact with another one to give a different substance that maybe it is going to give a negative repercussion to whatever you are doing or a positive impact to whatever you are doing. So you have to be able to choose the right material. So that takes us to our second subtopic area, which is choosing the right substance. Choosing the right substance. I've just mentioned the basic areas we need to know, and from those basic areas, then one can easily be able to at least choose a particular item to be used in a particular area. When you look at choosing the right substance, maybe to understand this part well, we have to pinpoint a particular item in our life. And from that, we can now start building our story of how can we choose the right material for that particular item or items. So I want us to look at three different situations. Number one, we want to look at our skyscrapers. Number two, we shall look at something like jumping castles. Then number three, we shall look at packaging materials. Packaging materials. Now if you look at these three things or three areas, these are things that are with us in our life. Probably in that classroom you are attending this lesson to is a storage building. If it is a storage building, imagine if the ground floor was weak. Will the second, third, etc. be held? Floors? Not at all. Look at that jumping castle, if you have ever been in one. How is it? What is it that has been used to make it? Looking at packaging materials, I'm sure you have passed so many areas and you just feel like crying. But you pass some other areas and you smile. Why? Because of either the litter that has been thrown all over, polluting the environment. And this is due to the packaging materials that have either been thrown anyhow or have been properly arranged. And that's what will make you either cry or smile. Packaging materials, the plastics, very a nuisance if not well managed. But if well managed, then they become very good for us. However, not very good, as we shall see further description or further explanation to do with these packaging materials. So let's go back to our first aspect of analysis to see how choosing of materials is very important. Now, having understood a chemical change, having understood that if a chemical change takes place, it either makes a substance weak or strong. Remember rust? This makes somebody to choose a material. I want to build a skyscraper. This is a building that may be having even 50 floors. This is a heavy structure. Do you think such a person will invest a lot of money in that building, whoever the person or the government, and use a material that within a short period it will undergo rust, and after rusting the material becomes weak, and if it is weak, what next? The building goes down within a short period, probably maybe 20-30 years, and yet the building is supposed to stay for 2 to 3, 4, 5, even 600,000 years. I mean 600 years. If it is iron, can it reach there? Obviously not. So you find that because of that, you have to look for a material that will be able to resist some of those conditions. And that is, you use steel. You use steel and not iron. So skyscrapers, you will find that instead of iron, steel is normally used. Why? You will have put into consideration this chemical process called rusting. Rust cannot take place on steel. So steel is rust resistant. That will have helped you to choose a material by you having understood that there is chemical change and there is physical change. And in chemical change, there is change of the material. And in change of the material, you may change the strength of the material to either to the negative or the positive. For example, rust is to the negative. So you have to look for a material that is rust resistant, and that is steel. I think that's so good. Let's look at a jumping castle. This is a structure from far you may think is a solid structure made of probably cement or metal. But in reality, it is made of a material that can hold air. Such that when that material has been maybe carried to a certain place, you inflate in air. For you now to be able to inflate in air so that it takes that shape that is strong enough, but will give you that enjoyment you want of being able to jump on it. When you jump, is like you are being springed up and down. That ability can only come if you have the knowledge of the material. You have to realize that the material must be able to be, one, hold air, airtight. Not any other material. Any material can be used. You can't go in for a clothing material. No way, because this one will not be able to hold air. Number two, the material should be smooth. Remember, in that castle, we also have even very small kids that will be enjoying in it. So if it is rough, I'm sure the child will never be able to admire again to go back to that place. And if you are a parent, then you will not be very comfortable with such. So the material must be smooth. The material must be flexible, so that when you spring at that point, when you jump up, as you go down, you will press the material downwards. But the material should be flexible enough and tough enough to spring back, to push you back, so that you can now spring up and high. What are we seeing? We are seeing a material that has a certain property. A certain property. And for you to get that, you need to understand the chemical properties and also the physical properties of that substance, so that you'll be in a better position to choose which material to be used where. So as you can see, a fabric cannot be used, and maybe a plastic material will be comfortably be used. But even that plastic material, you need to realize that not all plastic materials can be used, or leather can also be used, but not all type of leather. It has to be made in a particular way so that it fits the use. So the physical and chemical properties, very important in assisting you to choose which material is right for which purpose. Now, of these three, to me, my very big point of interest is number 3, packaging material. Why am I so much interested in packaging material? Maybe when you talk about skyscrapers, you are not yet there. You are not yet able to be involved in building skyscrapers. You are not an engineer yet. When you talk about jumping castles, maybe some of you are not fans of such. Maybe at one time you are involved in a game there, enjoying it, but you're not a fan of it. But let's look at packaging material. In one way or another, you just have to use it. And it is this point that makes our environment cry. It is crying, literally crying. We are killing it. We are destroying our own environment because of this. And now, you, as a young scientist, you have to learn this. You should be able to choose the right substance to be used as a packaging material. Look at glass. Glass is used as a packaging material. Soft drinks and so many others. We use glass. We also use plastics as packaging materials for the same soft drinks and others. Look at styrofoam. When you want to carry or to package maybe food material, you want it to at least maintain some heat. You will not just go and pick any other material. You will go in for styrene or styrofoam, which is able to at least act as if a thermos flask. It will keep that bit of warmth of that particular food material. Look at this aspect of you coming from a shopping mall somewhere. You have so many items. You will require somewhere big or bigger to carry all those other items. You need a bag. or you need maybe kind of a shopping bag. Which materials this shopping bag has it been made of? Very important. So because of that, we need to learn so many issues to do with the packaging materials, and that is recycling. We have to learn something to do with the recycling of materials. Recycling of materials. And in recycling of materials, we have to understand that materials can be, in general, be categorized into two. That is, biodegradable and non-biodegradable materials. Bio and non-biodegradable materials. So our starting point is we are looking at packaging materials. These packaging materials, we have to be very reasonable enough to save our environment by making sure that after you have used, reuse it in what we call recycling. But for us also to look at recycling as a good activity in our life, we have to understand that materials can be broadly be categorized into biodegradable and non-biodegradable materials. So let's see what is this that we mean by biodegradable materials. These are materials that, when left for some time in favorable conditions, they are easily broken down within a short period naturally. Within a short period naturally. And this is normally done using bacteria and fungi. Bacteria and fungi, which are commonly found in the soil. Bacteria and fungi are commonly found in the soil. So any material that you can bury in the soil, and within a short period, if you go check, you will not find it, then you call such a material a biodegradable material. These are the materials that you and I should encourage each other to use in our general lives, and more so as packaging materials, because if it has undergone that rotting, it has been decomposed, then it means you will not be seeing it as a nuisance material around you. But we also have those that we call non-biodegradable materials. These are materials that do not undergo degradation, do not undergo decomposition, do not rot naturally within a short period. They may take a very long period, even hundreds of years, for that material to disintegrate. Who will be there for those hundreds of years to see such a simple material, like now this one, this is plastic, to see such a simple material disintegrate? Now you can imagine if we have millions of this thrown somewhere, not in any way being used, then that will be choking our environment. So those are what we call non-biodegradable materials. Now, what are the effects of these non-biodegradable materials? When they are thrown anyhow, not in a particular way, for example, the polythene bags, they may be taken in by animals or cover some animals and plants in particular ways that they interfere with the normal operation of those animals or plants. Like I just spotted at one time a polythene bag that was flying due to wind, and it had to stick itself to a bird that was just walking around. And since the bird does not have hands and does not maybe have that brain to probably uncover itself from that both in the back, it had to struggle, and by the time somebody was there to reach to the bird and assist it, it had already suffocated. What is that? That's pollution. We are killing the environment by just having these non-biodegradable materials which will be flying all over the environment. The other effect to this is they interfere. That was just to do with maybe the air. But look at the soil. Look at water bodies. You will find that in water bodies, you will find some bottles and some other plastic materials that are thrown in lakes and oceans, such that they interfere with the colonies of fish, the breeding points of these fish. And with the time, you will find people complaining that now we don't have enough fish in particular areas where we used to imagine that we shall never have any deficit of fish at that particular point, just because there is a deposition or dumping of materials that cannot be disintegrated within a short period. Now then, how best are we supposed to handle these non-biodegradable materials? The best way you have to handle non-biodegradable material is, number one, do what we call recycling. Very important point. Do recycling. Use a material that you know you can still reuse it. For example, if you have a shopping basket, which you know, even if it gets dirty, you can still wash it, you can still wash it and reuse it, then that is the best way to go. Recycle the material. Number two, know how to dispose it. In Australia and so many other countries that are very careful with the environment, you will find that they will always categorize the dumping point of materials that by describing the material, that this type of material should be placed at this point, and this type of material to be placed at this particular point. You will be looking at the physical and even the chemical properties of the substance as you dispose it to that particular point. You will find that containers to hold maybe plastics will be labeled plastics. Those to handle glass materials, they will also be labeled. Those to be handling things that can easily rot, those that are biodegradable will also be labeled, so that when it comes to the point of collecting to a common point, you don't mix. If the three are mixed, even if part of it will be biodegradable, what will you do to this glass? What will you do to this plastic? It becomes a bit hard. So you find that by you disposing these materials in the correct manner, this glass or this plastic or these biodegradable materials will easily be taken to the rightful place for recycling. Plastics can be recycled, glass can be recycled, and this one can also be reused, but in a different form, because as they undergo that decomposition, they form what you call manure, which can be used in the farms, or even some are used in making fertilizers, which is very important in agriculture. What you have done is you have emphasized yourself on recycling by disposing your materials in the correct manner. The other way you can handle this aspect of non-biodegradable material, that is in addition to recycling and disposing them very well, is choosing materials that are commonly used. Choosing materials in areas that is commonly associated with the non-biodegradable material, but you choose biodegradable materials. For example, scientists have just come up with the biodegradable shopping bags. Why? Because they know as much as there is enough, or that is open to discussion, there is enough information out that this type of material is interfering with the environment, but people will always tend to go against it. So to save, then instead of using non-biodegradable material in making shopping baskets or bags, then go in for biodegradable material, which comes from specific types of plant material. However, unfortunately, this type of bag is very expensive. The bag is very expensive, and again, it cannot be easily reusable, because after some time, since it is biodegradable, it can easily be destroyed, and people are not fan of it, because they feel this non-biodegradable material can easily be reused. So it becomes good if you have that knowledge of reusing it. But if you don't have that knowledge of reusing it, then it becomes a nuisance to the environment, and especially if you are not going to dispose it very correctly. Now, we have talked so much about this aspect of shopping materials, and in particular biodegradable and non-biodegradable. So I will wish maybe we at least identify 2 or 3 items you think are made of biodegradable material, and again 2 or 3 items you think they are made of non-biodegradable material, so that as you move around, you now know I should look for this type of material when I want to package my items. So let's start with the biodegradable material. Biodegradable material. Biodegradable material, one of it is what we call cellulose. Cellulose-based bag. Now, cellulose, as you can see, cellulose is a description of plant cell. A plant cell. In a science under category of biology, as a branch of science, you will learn cells, and we have animal cell and plant cell. So, plant cell has a cover, what we call a cell wall. That cell wall is made of a material called cellulose. So it is that cellulose that has been used to make that bag. This is what I've called a biodegradable shopping bag. It is expensive just because it is environmental friendly, and since it cannot be reused so much, that's why maybe some are not very comfortable with it. Another one is paper packaging material. Paper. They normally come in maybe beige color, most of them. Paper packaging material. Sometimes we call them just boxes. These are biodegradable shopping materials. If you go to any shopping point and your materials are packaged in such, feel happy because you are an environmental friendly person. But if you feel that maybe they don't look that beautiful, they are ugly, then you may be feeling happy carrying the other type of bag, but you are only destroying your own life, though indirectly. Then we also have cardboards. Cardboards, like especially heavy maybe implements or whatever, you'll find that when carrying them, you may be packaged in such. When you see a cardboard, as much as it is hard, but that material, if buried in the soil for some time, not a very long time, but for some time, then within that time, you no longer see it. That confirms to us that that is a biodegradable material. So this gives us a hint of the materials we are supposed to go in for when it comes to shopping. Maybe an addition here, it will be bad if I don't include this, fabric. We talk about fabric. Fabric-based bags. This is one of the best. Why? Because it comes from a natural product called cotton. Fabric comes from cotton, and cotton is natural. So that's why when you bury a piece of clothing in the soil, so long as it is pure cotton, then in a reasonably shorter period, you will no longer find the fabric. But if you find the fabric is still intact, then know that that fabric was not made from natural product. So look for fabrics, and particularly fabrics from natural products. We have cotton, we even have the skin. We have the skin, it is also a natural product. We have wool, that's a natural product, and so on. So these are the materials you and me should always insist on using for our future generation. Otherwise, we may die with our environment. Now, examples of non-biodegradable. Examples of non-biodegradable materials. These ones, I'm sure probably you are even having it right now. If you have ice cream or you have just had ice cream, where was it packaged? Where was it placed? That material that you are given carrying the ice cream is a non-biodegradable material. That is, we have polystyrene. We have polystyrene, very common in being used for packaging. At one time, probably you have had chocolate. Does the paper used for wrapping that chocolate appear like the normal paper? It isn't. So that is chocolate packaging. We have the chocolate packaging. Paper, chocolate packaging paper, and similar items that are packaged in such, like especially that paper that is normally used to wrap maybe items as a gift, unless it's a box. There's that presentable paper people normally use to package items. Maybe you want to present it to your friend as a surprise birthday party. That piece of paper you use, if you bury it in the soil, after a year, go check, it will still be intact. That is a good example of a non-biodegradable material. Another one is glass. Glass, which is a very common packaging material for soft drinks. It is good. In fact, glass is the best. When you compare glass and plastic, glass is the best. But now the problem is it is an non-biodegradable material. So one must be very careful on how it is supposed to be disposed of so that recycling can be much easier. Then we also have paint. Paint is a common material, and somebody may wonder why mention paint under kind of packaging material. If you have items placed somewhere for transportation, and maybe they are going to pass through a very harsh environment, the easiest thing people do is just paint the item with oil paint for the item to be in a transit. It has to cross maybe the ocean for a very long time and distance. So the paint will be so good. And like maybe you want to cover with the fabric and all that, paint will always do. So this is a material, and remember, paint being non-biodegradable, it will always cause problems. We also have metals. Maybe food that has been kept in cans, like spaghetti, canned spaghetti. You will find that it is packed in cans. Cans are made of a metal, tin. Tin is a very common metal that is used in packaging, and you don't expect tin to undergo decomposition as fast as these other materials that we have just mentioned under non-biodegradable materials. So these are examples of non-biodegradable materials that we are commonly using, and without good knowledge, you will be destroying the environment. They are not bad for them to be used, but use them with a lot of care and mindfulness to the environment. Now, today we have been looking at chemical properties of substances, which is in addition to physical properties of substances. And having identified the physical properties and the chemical properties of substances, we have been given the power to be able to choose materials on basis of where they are to be used. So, using physical properties and chemical properties, one is supposed to be able to choose the rightful substance on where to be used and how to be used. So, to finish off my lesson, may I just ask you to answer for me this particular question. This is the question. All of us as human beings, we produce waste products. That is feces or poo, as you call it in your other ways, or urine. Those are the two major waste products we can talk about. Are these materials biodegradable or non-biodegradable? The answer should not just be bio or non-biodegradable. Try to explain why they are categorized in that particular category. The answer to it is our waste products are non-biodegradable. To explain this, poo, as we call it, when stored in a particular condition, and in fact at high-tech levels, it is normally used as a material in biodigesters to produce biogas. So during that production of biogas, using that poo, whether it's from you as a human being, as I'm talking about, but you can also have it from other animals like cows and poultry, they undergo decomposition within a short period to produce a gas that we call biogas. That is just a confirmation that the material has undergone decomposition change, which is a chemical change. And when it goes out, you find that things like the smell also goes down. That confirms to us that poo is a biodegradable material. That marks the end of our lesson today. Thank you.